Dear learners, a warm greetings by Department of Chemistry, School of Science, Tamil Nadu Open University. Myself, Dr. P. Shanmugavelan, Assistant Professor, Department of Chemistry, Tamil Nadu Open University. Dear students, now we are going to discuss about principles and importance of green chemistry. Before going to our topic, we have to know about what are the incidents happened due to the chemicals and its pollutions. We well know that in Japan, one fire accidents happen due to harmful chemicals in a river called Suyang River in Ohio. In our India, we well know that Bhopal gas strategy, where we have lost nearly 4,000 people died due to the release of methyl isocyanate in the industry, chemical industry. These are all happens due to the harmful chemicals and its effects. Then what are the chemical pollution sources? We have to know about the what are the sources of pollution due to the chemicals. We will know that in many industries as well as the industries may be chemical industries or other industries where fumes were evaluated due to the chemical reactions, as well as in dye industries dye pollutants are mixed with the river water, as well as pesticides, insecticides. In agricultural field we used the pesticides in insecticides. These are all polluted our soil. We have to know about the chemistry and its application play a vital role in many industries such as medicine. Green chemistry is a tool for innovation which includes business, education and economy to build a sustainable future. Hence, we should now concentrate on innovation in green chemistry to reduce the environmental pollution as well as damage due to the generation of hazardous substances and the reactions. In our current globalized world, green chemistry has become the strength leading towards sustainable development. It is evident that many academic institutions and industries recognize the importance of innovations in green chemistry. It is imperative to teach the value of green chemistry to future generations. It's our duty. Then, what is green chemistry? Green chemistry is nothing but design, innovation, application of chemical products and process that reduce or eliminate the use of generation of hazardous substances. It is also well known as environmentally benign sustainable chemistry. Then why we need of green chemistry? What is the purpose of green chemistry? Chemical developments bring new environmental problems and harmful unexpected side effects which results in need of greener chemical products. Also, there is an increasing pressure from both society and governmental side for chemistry based industries to become sustainability. Then what are the goals of green chemistry? Here we should know some goals of green chemistry one by one. First one is waste minimization at source. Second one, use of catalyst in place of reagents. Instead of reagents, we should try for use the catalyst. Then instead of toxic reagents used, we may try for non-toxic reagents. Another one is renewable resources. For a chemical reaction, we have to alternate our renewable resources for the reactions. Then improved atom efficiency. Then another one is use of solvent free or recyclable environmental free or solvent free systems. In a simple way, we can say what is green chemistry. Green chemistry is about reducing the waste, materials, hazards, risk, energy as well as cost. A familiar chemist who is known as Paul Anastas, have derived principles of 12 principles of green chemistry. That's why he is called as father of green chemistry. We can see the principle one by one. What are green chemistry principles? One is prevent waste, maximize atom economy, less hazardous chemical synthesis, safer chemicals and products, safer solvents and reaction conditions, increase energy efficiency, use renewable feedstocks, avoid chemical derivatives, use catalysis, design chemicals and products to degrade after use, analyze in real time to prevent pollution. Final one is minimize potential for accidents. We can see the explanation for each principle one by one in next slide. First one is prevent waste. From the pictorial representation, you can easily know the how we can prevent the chemical waste. For prevent the chemical waste, we should design the process which minimize the chemical waste. Better to prevent waste than to clean and treat. Better one. Then atom economy. From this figure, you can easily understand the what is atom economy. Atom economy is nothing but the conversion efficiency of a chemical process in terms of all atoms involved. Here, one is formula to find out atom economy. That is, atom economy is nothing but molecular weight of desired product divided by molecular weight of all reactants into 100. Here one example for atom economy reactions. Choose transformations that incorporate most of the starting materials into product, increases the efficiency and minimize waste. We will know that Claisen rearrangement. Herein atom economy in a Claisen reagent is 100%. In Wittig reactions to only 20%. Let us choose the type of reactions like rearrangement, addition, substitution and elimination which shows more atom economical. While we conducting reactions, first we should know what is the preferable reaction to give a more atom economy. Then less hazardous chemical synthesis. In this pictorial representation, we can easily know the hazardous chemical synthesis in a lesser way. Wherever practicable or synthetic methodologies should be designed to use and generate substances that possess little or no toxicity to human health and environment. Herein we can compare two reactions: polycarbonate synthesis, Pauzian process. Polycarbonate synthesis using solid state process. Herein more advantages towards solid state synthesis instead of Pauzian synthesis, because Pauzian synthesis towards solid state process have more advantages like elimination of less hazardous chemical waste. Then designing safer chemicals. Chemical products should be designed to preserve efficacy of the functions and reducing the toxicity. Dry cleaning agents. Initially, in earlier days, we can use gasoline and kerosene for safer dry cleaning agents. Then it will move on into chlorinated solvents instead of gasoline and kerosene. In future, we will go to the supercritical or liquid carbon dioxide for the cleaning agents. Use safer solvents, reaction conditions. From the figure, we can easily understand how the use of safe solvents and reaction conditions in a chemical reaction. The use of auxiliary substances like solvents, separation process and reagents should be made unnecessarily. Use safer solvents and reaction conditions that involve solvent substitutions, water as solvent, new solvents like ionic liquids, supercritical fluids. Then sixth principle is increase energy efficiency. Energy requirements should be recognized for their environmental and economical impacts and should be minimized. Synthetic methods should be conducted at ambient temperature and pressure. And seventh one is use of renewable feedstocks. From the pictorial representations, you can find the renewable feedstock. Yeah, herein a raw material or feedstock should be renewable rather than depleting whenever technically and economically practical. Traditional feedstock in synthesis of adipic acid, then alternative feedstock in the synthesis of adipic acid. Here we can compare the efficiency of green chemistry by the both reactions. Then reduce chemical derivatives. Unnecessarily derivatizations and deproduction, temporary modification or physical chemical process should be avoided whenever possible in a chemical reactions. More derivatives involves additional reagents, generate more waste products, more time, higher cost and higher level use of starting materials. Hence, it requires to reduce derivations. Then, use of catalysis. Catalytic reagents are superior to stoichiometric reagents, readily regenerator separated, recyclable and mild conditions. These are all the advantages of using a catalyst while we conduct chemical reactions without using the catalyst. We can know that catalysts make the reactions faster, decrease the energy requirement, can produce single desired product and minimize waste, more chemical waste. While we using catalyst in a chemical reactions. Then 10th one is design for degradations. Chemical products should be designed so that at the end of their functions they do not persist in the environment and instead break down into innovative degradation products. Example CFC and DDT, biodegradable polymers. These are all the examples for design of degradations. Then real-time analysis for pollution preventions. Analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Real-time analysis for a chemist is that process of checking the progress of a chemical reaction as it is happens, knowing when your product is done. The final one is inherently safer chemistry for accident preventions. Substances and the form of substances used in a chemical process should be chosen so that we can minimize the potential of chemical accidents, including release and explosion of fires. Then various industrial accidents we can prevent while using this principle. Then we can move on to what are the green solvents. Solvents are substances that require liquid during application and will dissolve other substances which can be re-recovered on removal of the solvent. Research in green chemistry is making the dramatic achievements in the design of chemicals, chemical synthesis and chemical processes that are environmentally benign and economically feasible. The goal of green chemistry is to reduce the hazards associated with the products and processes. The idea of green solvents expresses the goal to minimize the environmental impact. Then what are these green solvents in green chemistry? In general, many solvents used for chemical reactions. Of them, we can categorize what are the green solvents. Water, methanol, nitromethane, acetone, ethanol, DMF, DMSO, HMPA, acetonitrile, pyridine and ammonia. These are all the green solvents in a green chemistry process. Water as a reaction medium. Because water is a green solvent, while we using the water, we can have a more advantages in a chemical reactions in point of view of green synthesis. One of the most obvious alternatives instead of other organic solvents, cheap, readily available and plentiful, useful for certain types of reactions but limited because of low solubility of organic substrates and compatibility with the reagents. cleanup process will be very useful in a biophasic process in conjugation with other solvents. Then carbon dioxide. Carbon dioxide have the more advantages than other organic solvents in compared with other organic solvents in point of view similar advantages to water, that is natural, cheap and plentiful, are available in 99.9 pure form, byproduct of brewing, ammonia synthesis, combustion, already being adopted in a variety of commercial processes. No solvent effluent while we using carbon dioxide. Then ionic liquids typically consist of organic cations and inorganic cations. These are called ionic liquids. Instead of other organic harmful solvents, we can use the ionic liquids as a green solvent. Ionic liquid as a green media have more advantages. These are all the some important reactions where we are using ionic liquids instead of organic solvents. Diels order reactions, alkylation reactions, hydroformylation reactions, Friedel-Crafts reactions, and alkene polymerization, biotransformation reactions, where we are using ionic liquids. Then ethyl lactate is a renewable solvent. Then we can move on to what are the green synthetic strategies. In conventional chemical synthesis, we are using many synthetic methodologies where many harmful organic solvents are used. In point of view of environmentally benign organic synthesis, green synthetic strategies should be followed. Many green synthetic strategies available in literature, we can see one by one. First one is solvent-free synthesis, water promoter synthesis or water mediator synthesis, one-part synthesis, multi-component synthesis, microwave synthesis, and mechanical stirring synthesis. These are all the synthetic strategies using the green protocols. Then, what are the importance of green chemistry? In human health point of view, there are many importance of green chemistry applicable. One is cleaner air, cleaner water, increased safety for workers in the chemical industry, safer consumer products of all types, safer food, less exposure to toxic chemicals. These are all the advantages of green chemistry in human health point of view. Then environmental health point of view, many advantages using the green chemistry. Many chemicals end up with the environmental by intentional release during use. Plants and animals suffer less harm from toxic chemicals in the environment. Lower potential for global warming, ozone depletion and smoke formation. Less chemical disruption of ecosystems. Then less use of landfills, especially hazardous waste landfills. Then in economy and business point of view, there are many advantages while using the green chemistry. Dear students, thank you for patient listening. If you have any questions, mail me or call me. Thank you so much. Thank you.